I'm your host, Diana Bruin, an expert in PKD, nutrition, and all things kidney health. If you believe there is more you can do with nutrition to slow the progression of PKD, but you aren't sure why or how, the PKD Dietitian podcast is just for you. We'll look at the science and research around PKD. I'll break it down in ways that are easy to understand. And of course, we'll dig into all things nutrition and PKD. I'll answer your questions and those that I frequently get from clients and medical professionals. Along the way, you'll meet researchers and PKD warriors, highlighting the power of advocacy, awareness, and community. Let's get started. In this first episode, I want to take you on a journey looking at the history of PKD and science and research breakthroughs. Sometimes it takes a look back in order to look forward. We'll be moving from history to hope for finding a cure for the teardrops of the kidney. The year is 1586. Stefan Batory, the King of Poland, returns from a hunting trip and soon falls ill. His symptoms are documented over the next few days. However, he does succumb to his illness and passes. Because he is a king, he is embalmed, and that embalming, we have great detail about his autopsy, and it's noted that he had stones in his gallbladder, and his kidney was large like that of a bull. Now, we'll come back to the King of Poland at a later time. It wasn't until the late 1700s that medical professionals really started becoming interested in and exploring PKD. Why is that? Well, now we're up to the 1800s. So in the 1800s, there was an increase in the number of autopsies done. And because of this, kidney cysts were being defined in much more detail. And frequently, when cysts were seen on the kidneys in autopsies, they were called the teardrops of the kidneys. And I quite like this expression describing them. In 1888, Felix Legars, in his doctoral thesis, first used the term polycystic kidney disease. And what I find interesting is that in that same thesis, he wrote that treatment of PKD should be with diet and hygiene. Now, I'm not quite sure about the hygiene part, but I 100% believe in the diet part. Move forward about 10 years, and in 1899, it was first recognized that there was a genetic component to PKD because patterns of inheritance were seen. Now, really, in the 1800s, primarily in the later 1800s, science was not able to look at these patterns. And so really what was in place were theories about the path of cyst development. However, the medical professionals were able to clinically recognize and identify some signs and symptoms of PKD. So now we're moving into the 1900s. In 1933, Poland celebrated the 400th anniversary of the birth of King Batory. So we're back to the King of Poland. And for part of that anniversary celebration, Professor Walter of the Krakow Medical School invited several historians along with a group of medical students to review the documented autopsy findings of Stefan Batory, the King of Poland. After reviewing them in depth, the conclusion made was that the king had PKD, and complications from PKD were most probably the cause of his disease and death. So King Batory of Poland is the very first recognized and established case of PKD in history. In 1982, the PKD Foundation was established. And in 1985, chromosome 16 was identified as the location of the gene for ADPKD. So now we're going to get into the mid-1990s, where science really started catching up with theories and its ability to look deeper. In 1994, the gene for PKD1 was discovered. This was a huge breakthrough. Shortly after that, in 1995, the PKD2 gene was discovered. Why is this so important? Because once the genes were identified, research kicked into high gear. So when we know the genes involved in a disease like PKD, we know what the genes code for. We also know what functions they are involved in the body, and we can look at the pathways that they affect. This is huge. In 1999, another moment of discovery was in a preclinical animal study. It was shown that using a drug to block the hormone vasopressin slowed cyst growth. Now, between 2004 and 2009 was really an explosion of research, an explosion looking at and digging into the pathways of PKD and the pathways that drive cyst formation and growth were identified. Why is this important? If you know the pathways that are driving cyst growth and formation, it makes for a very targeted intervention opportunity. And for sure, the pharmaceutical companies started paying attention. So in 2002, the gene for recessive PKD, AR-PKD, was discovered. In 2003, the CRIS study concluded, and this was the one looking at images of the kidney using much more detailed MRIs, and what they found was that the kidney size, the total kidney volume, was a very strong marker for progression of PKD. They saw a strong relationship between total kidney volume and function. In 2009, the FDA approved tolvaptan. Now, you heard me right, 2009, tolvaptan was approved on the market. However, it wasn't used for PKD at this time. In 2012, the Tempo 3-4 trial completed. This was the study looking at tolvaptan as blocking vasopressin, that hormone that was mentioned earlier. And what this study showed was that tolvaptan, as a vasopressin receptor antagonist, had the ability to impact cyst growth and to slow it. Now, moving forward, there really is a discovery or a revelation almost every year up until the present. And that really shows you progress in our lifetime that has made in understanding and combating PKD. In 2013, it was discovered that the cyst in the kidneys have an altered metabolism. They prefer blood glucose. And the cyst cells, unlike any other kidney cells, really have an affinity for blood glucose to use for their energy. In 2014, the HALT PKD study completed, and this is the one that looked at whether a combination of 2 blood pressure medications was better than one in managing hypertension and outcomes with PKD. No big benefit was found with having 2 blood pressure medication. However, this study was an absolute big deal because it was the first prospective randomized control study funded by the NIH. So you can see research is getting funded. In 2015, the FDA labeled total kidney volume as a predictive marker for PKD progression. In 2016, preclinical animal studies showed that food restriction, even a small amount, slowed the progression of cyst growth and thus the progression of PKD. And what is interesting about this is it 100% shows a connection between energy and nutritional components and PKD. Now, in 2018, tolvaptan was approved in the US, and this is the first treatment on the market for ADPKD. For those of you listeners outside of the US, was approved as early as 2014 and 2015 in other countries. In 2018, tolvaptan was approved in the US as the very first medical treatment for ADPKD. Now, for those of you who are listening outside of the United States, tolvaptan was approved as early as 2014 and 2015 in other countries. That same year in 2018, work coming out of the University of Colorado looking at weight status and obesity and progression of PKD showed a strong relationship between obesity and faster progression. Again, there is a nutritional component in that research. In 2019, the National Registry for ADPKD launched. This is very important in moving research forward, but also in connecting the PKD community. In 2019, Congress named September 4th National Polycystic Kidney Disease Awareness Day. In 2019, research coming out of UC Santa Barbara and the Wimes lab looked further into the idea that a reduction in food intake slowed cyst growth. And they took those studies several steps further and identified that the key component in the reduction of cyst was a ketone called BHB, beta-hydroxybutyrate, and further looked into ketosis, therapeutic fasting, and time-restricted eating as a way to combat PKD. In 2020, the Renew Group program launched, and this was a collaboration between the Wimes lab and Renaline, taking that information and research from Santa Barbara and translating it into a kidney-friendly ketogenic approach for PKD. This was the first group program and nutritional intervention available outside of studies. And then in 2021, Santa Barbara Nutrients came out with the very first medical food for PKD called Keto Citra. So now we are pretty much in present day, and you can see that there has been, in the last 5 to 10 years, great growth and momentum in understanding and combating PKD. And that's in our lifetime. And the takeaway for you is that I want you to take this history and move from a place of history to hope, to know that you are part of moving this progress forward and further research and further understanding. And also that knowing that the pathways that drive PKD are nutrition and nutrient dependent. That's all for this episode. Thanks for listening. Make sure to hit subscribe and share the PKD Dietitian podcast with anyone you would think would benefit from listening. Any links mentioned are included in the notes from today's episode.